Uh, Backup recording on, and Shar, it's all you.
All right. Yeah, I'll be taking this one, Sean, but thank you for getting us going. Yeah, welcome to the Identity Special Interest Group on August 10th. Hang on, I'll go ahead and share my screen so we can follow along here. Can you all see this?
Yep, looks great.
Perfect. Well, yeah, so today we have two main things on the agenda, which is some working group status updates and then a presentation from Nick Steele on credential migration for wallets and credential providers. So thank you for joining us, Nick, and looking forward to your presentation in just a little bit here.
Of course.
So yeah, let's jump right in. Some announcements. Hyperledger has an in-depth webinar on Infosys on August 24th. So go ahead and register here if that's something that's interesting to you. And then I believe this Hyperledger identity campaign.
Yeah, I can jump on these, Tim. So these 4 bullets, just the Q3 editorial campaign is Hyperledger identity. So if you have news, please let us know. We'd love to signal boost at pr@hyperledger.org. Next one, Animo, who are fantastic contributors to Hyperledger Aries and maintainers of some of them are maintainers of Hyperledger Aries framework JavaScript. Have recently announced making Aries framework JavaScript a global framework. You can find out more at that link. Basically, they're going to be raising money from funders and finding teams who want to build out required infrastructure for Aries, and that's really exciting and something we love to see. Lisi recently announced a new messaging feature for their agent and wallet. You can find out more there. The Lisi team is writing a blog post. They're going to post that to the Hyperledger blog shortly. And then lastly, Hyperledger Indie community is going to hold the second Hyperledger Indie Summit on September 7, 2023. The first one, honestly, was the best 4 hours I've spent on Indie since I left Evernon years ago. The event's going to gather the entire community together, talk about the current state of Indie, the future state of Indie, what needs to get done. This is being driven by the maintainers and the contributors. This is, I mean, it's literally not a Hyperledger event, but we think it's super important, and we welcome everybody from this call to join. Back to you, Tim.
Awesome. Thank you, Sean. Yeah, well, we'll go ahead and jump into some working group updates then. It looks like the Hyperledger Indie contributors working group met on the 1st of August. Was anyone able to attend this session that would be able to give us a summary here?
Yeah, so on that call, I was as well going to mention the second Indie Ecosystem Summit on September 7th that Sean just talked about. So I'll send out the link as well to register if anybody on this call would like to do that. Definitely encourage you to do that. We also talked about did Indie VDR work be merged into main, deprecating the Indie SDK, and then as well the draft of the Indie quarterly report. So somewhat of a short meeting, but got through some good topics.
Absolutely. Thanks, Shar. The Aries working group met just yesterday, it looks like, on the 9th. Was anyone able to attend that session?
Oh, yeah, I attended the session. They spent most of the time, from what I remember, talking about the EU EIDAS guidelines, I think, finally were published, and they were talking about possible ways to support the protocols and specifications that Europe had that were far different than what I guess Aries and DITCOM were opinionated about.
Okay, sounds good. Thank you, Charles. Looks like the bifold users group has not met super recently. Aries Cloud Agent Python users group met on the 8th. Was anyone able to attend that session? All right, looks like they were discussing a non-creds Rust and Akapai. Aries Cloud Agent Python maintainers met on the 1st. Was anyone able to attend this session? All right, looks like they are getting some kind of PR together and then had a discussion. Aries JavaScript met on the 3rd. Was anyone able to attend the Aries Framework JavaScript meeting? Okay, looks like they were mainly discussing unqualified DID migration and DID peer 3 support, some other things. Versus Hyperledger and non-creds met on the 31st of last month. Was anyone able to attend this non-cred specification working group meeting? Okay, looks like they were discussing CL signatures. Trust over IP. Looks like the governance stack met on the 27th of July. Was anyone able to attend this TOIP governance stack meeting? All right, looks like they had a presentation from Michael Parisi, and if that sounds interesting to you, you can find it at this link. Looking okay, it looks like the TOIP concepts and terminology group met on the 31st of July. Did anyone make this session? Okay, looks like they're working at TEV2 amongst other things. Did come, could not find it. Looks like the diff didcom users group met on the 7th. Was anyone able to attend this session? Okay, they've been looking at how to better market didcom recently and are working on some efforts to put a book together, it looks like. The diff honorability group hasn't met. I think we've met since then. I believe, unless anyone else has any other updates, that brings us to the end of our working group update section. So I'll give it just a minute here, and then I believe you can take it away, Nick, if you'd like.
Cool. Thanks for having me again. I'm gonna turn on my camera and share my slides in 1 second. And then I'll have these slides available afterwards and share them with the rest of the group here. So I'm going to go ahead and cut over now. Give me 1 sec. All right, can everyone see this deck?
Yep.
Cool. Right on. Well, today I'm going to talk about credential migration, which is still pretty early days. It's some work that oh, here, I'm going to turn my video on so you can see my face. Hello. Credential migration is some early work, and it's actually a bit of a misnomer. We started to call it credential import export, or now I guess it's being abbreviated to CRIMP, similar to shrimp. But if you have any better abbreviations, let me know. Credential import export is a better term for this, and we'll kind of discuss why as we go through this. But to give you some context of why we're talking about this, why this is a topic being developed, and why I'm talking about this specifically, let me start by doing the real humble thing and telling you all about myself first. So hi, I'm Nick Steele. I am a security person. I've done a myriad of things, starting mostly on the security R&D side. Back almost 9 years ago at Duo Labs. And then what Duo got acquired by Cisco, and during this time I spent a lot of time working with the Fido Alliance and W3C on a mostly WebAuthn standard. And WebAuthn is a standard I think folks are probably familiar with at this point, to deal with essentially passwordless credentials and passkeys, and we'll talk about that term. But it kind of started to be as this way to have a predecessor to U2F and UAF, and really merge a lot of the benefits of MFA and U2F these like hardware authenticators with the benefits or basically use those benefits for single factor first factor login, which is not really the right term for this, but we want to just have a single credential that we use to log in, and WebAuthn was really hoping to make this possible. So I started as a mostly on the R&D and security engineering side, and now recently have been a staff technical product manager over at 1Password. And it's kind of funny, I ended up at 1Password. I found this great slide that I made, I think in 2016 when I was still at Duo, where actually it was like, oh, 1Password is going to get blown away by WebAuthn. And so, it says LastPass and all these other providers. There's this great stat from Dashlane saying, everyone has all these accounts. And this is a great stat for why we need this credential import-export format. But, by 2020, users are going to have over 207 accounts and credentials for each one of those. And my thinking at the time was like, oh, well, WebAuthn, if we have WebAuthn, we won't need like Dashlane, 1Password, and all these other companies. But actually, I think it's at least come to me that like 1Password and Dashlane and Bitwarden, NordPass, Passvault, like there's a lot of other companies out there that are really, really well positioned to manage user credentials, especially for handling WebAuthn and acting as an authenticator in WebAuthn. 1Password and a lot of these other companies, these third-party credential providers, they're called, are in I think a more enfranchising state for in the industry. One of the big problems with WebAuthn credentials and other types of credentials right now, like Passkeys, is that there's very easy user lock-in, especially if users are using Apple and Google platforms to manage their credentials. They tend to be pretty restricted to those ecosystems and to the systems that are able to use those. So if I have, an Apple iCloud keychain account with all my passwords and my passkeys and all any other credentials, SSL certificates, it's really locked into that ecosystem. But then these third-party providers like, Dashlane and Bitwarden are able to allow for access to these credentials across different platforms through different modalities. It really opens the user up to have more freedom and sovereignty over their credentials and their identities, which is really what's I think going to become more important here, and I'm sure you folks are well versed in. So I was wrong back in 2017. These types of authenticators are not going away. They're probably going to become more prevalent as folks have more and more credentials, as Dashlane said, back in 2015. But the big reason I think we're talking about this, and by we, I mean Dashlane, 1Password, and all these other credential providers, is that passkeys have been a huge focus for us. And passkeys it has a lot of different definitions. This is more of the marketing term, and I think this is where a lot of confusion lies, is that there's really two big public terms that I'd say kind of float around, and this is the marketing one, is passkeys are a replacement for passwords that provide faster, easier, more secure sign-in, blah, blah, blah. But the real technical side, I'd say, of passkey is that they are a replacement for, or they're not a replacement, but they are synonymous with the idea of a discoverable credential. They're a credential that is managed by a client and authenticator, and then revealed to the relying party. And so you don't need things like usernames and additional referential information to be stored alongside your passwords or these types of credentials by the RP. I can go to a site and have my passkey be available through my authenticator and client without the RP having to do a lot of any additional steps to look up keys and whatnot. And they are supposed to be a replacement for passwords. A lot of folks are using them now for MFA. That's, in my mind, that's fine. You'll get spicier takes from other people, but they should be a replacement for passwords, and they are supposed to provide a faster and easier way to sign in, with the benefit of being more secure for both the user and the relying party or the website using it. So a lot of this conversation around Passkeys, because Fido is wrote the marketing material and has been doing it with Apple, Google, Microsoft. A lot of this discussion started in Fido, and Fido has a triannual plenary. The first one this year was in Dublin, and this is where myself and this is Ryu Islam from Dashlane presented our kind of view of what migration should look like, and now credential import export. And we got some pretty good feedback, and I'm here to tell you kind of like where we're at and where we're currently at, and a bit of where we were coming from. So at the Dublin plenary, we presented some work that we showed over over about a month. We just kind of like we're talking back and forth because Rue and I are buds, and we were like, hey, it would be cool if we could do this, like a better way, like a better secure way to migrate credentials between our two applications. And I think Dashlane had an internal hackathon, and they put together a demo I'll show you. And then we had a hackathon, so it really just like the stars aligned, and we were able to put together a really cool demo. And this kind of got us on the path of saying, hey, we should have a more standard way to deal with this, because both us and many other credential providers, including Apple and Google, struggle with this immensely. It's really it's really hard to transport credentials across these boundaries, these like platform boundaries. So we wanted to present at the Fido plenary this and it says BOF because it's the Fido Birds of a Feather plenary. It's a BOF talk. We wanted to present this work to try to gain some consensus and thought around like how we could do this with other folks. So the current state of import and export or migration for most companies is to output credentials into a CSV. If you've ever moved from one credential provider to another, you will see that it outputs a CSV, and as a security person, this is probably very concerning. So the CSV is also non-standard, which makes it worse. Importing the CSV is a bad experience both for the user, because sometimes credentials are actually lost in transit, like they just can't be parsed properly by the other side. And then on the developer side, we need to have pretty specific unmarshalling code for different types of CSVs we see. So we need to know if it's coming from LastPass or Dashlane or Bitwarden or one of these other companies, because their CSV is going to be a different format. Google, Apple, same deal. Their CSV is going to be a different format, and if we don't parse it correctly, we may just drop the credential. So unless the user tells us where the credential came from, we don't know where they came from. And we also don't know if they've been properly imported or exported in a lot of cases. We can just try to make a best guess, which is, what we do, but it adds a lot of development time, and everyone really struggles with this side of it. So we proposed a method where the credentials don't go into the CSV format. In fact, they stay encrypted through the whole process of the import export. And we want to provide a normative data format for these credentials as they go through this export. We also get attribution, which is really great. We want to be able to say with confidence where they come from, and this is especially important in the enterprise case. We should be able to say that X credentials coming from this provider. Do you want to do it? And we can get the user to actually give us some intent signaling here. They could potentially use a biometric, or at least they can have some say in the process of doing the import export, aside from just like importing the CSV that may be potentially malicious in some cases. This is really important for enterprises to have, because enterprise import and export is a really onerous task and kind of impossible in a lot of states. The other thing that we don't really have listed here that we're trying to accomplish with this standard is to do it in a format where you could do it for one or more credentials, and you don't have any guarantees around the network on which these are being transferred. It could be completely local. It could be semi-local. There could be a segregated network component where, you know, I'm moving credentials from my laptop, which is in my office on a WAN, and I put my migration file, and I'll kind of show you what that could look like, on a USB stick, and then I want to take it to my data center. And then, you know, maybe my data center is on a completely different network and actually unable to see if they're online or offline or not. But we want to be able to support these scenarios. So we have, this was like an early example, and there's a lot different types of modalities we're thinking of right now. But essentially, we want something like this in some cases. And after talking with Apple and Google, I think that they're more interested in using the OS, which is fine, but this would be a way for us to do it between applications without any additional steps. But what you can see here is we're, you know, on the import and export apps, we're creating this box. We drag the box over. The box is then filled with credentials and then sent back to the new the importer, the new application we're going to use, and then they decrypt and store the new credentials. So this is one modality we can do, and I'll kind of step you through the crypto of what's happening here, and then some new modalities that we're thinking about and where we're at in the spec. So, oh wait, sorry. So let's go to the next slide here. So really, what's happening here is, and we'll step through it kind of bit by bit, is if we look here into this top right quadrant, we're going to have a public key that the importing app supplies to the exporting app. So that's when, you know, when we create that empty box and drag it in, what's happening is that box is essentially just a public key. The exporting app then uses that public key and their private key to derive a symmetric key, which we then use to encrypt the data. And this is similar to ECDH. And we encrypt with this, and then bundle that encrypted data along with some metadata that includes the exporting app public key. Once we pass that back, the original importing app will use their private key, and then the exporting app's public key to, you know, derive the symmetric key again. And then we'll decrypt that data and store the credential data using that credential data format that, you know, we're hopefully going to develop here as well. So this was kind of the original thought, and this is still like a good way of doing it. But one could also do this using hybrid public key encryption, which is a newer standard and also developed by an old colleague of mine from Cisco, Richard Barnes, along with some other folks. This is currently, I think, an informative RFC in IETF, but we could potentially do key encapsulation here, where we actually just encrypt a key with the exporter's public key, and then they decrypt that and are able to encrypt with the negotiated or the encapsulated key. So this is also a method that we really do want to account for, and I think I've been talking with a lot more folks about recently. And so we'll kind of talk about like where things are at. But, you know, I don't want it to be I don't want this to be too prescriptive, but we should be using, you know, modern cryptography methods to make this easier. Another thing that we wanted to account for too, in the case of enterprise migration or even some consumer migration steps, is potentially the presence of an authorizing party, and this can work with the HPKE or I'd say Diffie-Hellman setup, but an authorizing party could essentially authorize. It could act as a credential authority throughout most of this. And so in the case of, you know, I'm at ExoCorp and we're migrating from password provider 1 to password provider 2, we could provide our own sort of authority to handle the public and private keys necessary for both of these applications to to migrate between each other, and also get approval or authorization from the enterprise to do so. So that's kind of like the three things we really we're looking at in terms of architecture. But the important overlap here is that we're using these modern public key encryption schemes. We're using things like Diffie-Hellman, which is tried and true, and we're using these hybrid public key encryption schemes, which could potentially be used in one-to-many scenarios, which is also something we might want to account for. And we're able to provide this user intent and provider attribution through these public keys. These keys could potentially be provided through an X509 certificate. So in the case we had that authorizing party, they could either issue the certificates or authorize or really verify the certificates being used. So we can get some better ideas around attribution and identity, not only of the user, but of the application. And then what we don't describe here really is that migration format, but this is really an early development and is going to help provide things like data integrity, hopefully, where we can, know for sure that certain credentials have been unpacked, or if they can't be unpacked, we know where they exist and can be used, or we have ways to remediate their usage. So this work also should be the foundation for further, I'd say, work with regards to authenticators, especially third-party authenticators like ourselves at 1Password, where we can deal with things like potentially referential integrity and credentialing, where we could either import a credential or reference, or if we can't import it, reference a credential from another wallet, and potentially ask for signatures against it. And this would, I'd say, look similar probably to like an OAuth flow, but that's all I think pretty far out. But by providing a lot of this work now, we can lay a path for this to be successful later on. So I mean, outside of that sort of referential foundation, the real reason this work is important now and in the long term is that this now raises the bar dramatically for user security during migration and import-export of credentials. Having in a lot of cases, when you import or export credentials, you're dealing with CSVs. And if you're not, you have to have this trusted middle party to migrate the credentials over for you. And in the case that you're online and you say, oh, hey, Dashlane, could you share credentials with X? Or 1Password, could you move your credentials over to Y? You usually have to have some other root of trust in there to handle that interim movement. This work would allow us to kind of have the user be able to not only provide their own threat model and account for their own security, but also they don't, in the case of bulk movement of credentials, you don't have this CSV anymore, and so that's going to be a huge lift. Multiple authenticators and credentials can lead to bad UX for users, but this has been kind of a not a requirement, but like a heavy ask since day one of WebAuthn, where we, our best recourse against things like account recovery and needing to deal with account loss was we would say that you should enroll many credentials, enroll as many WebAuthn credentials with the site as you can. But this also requires many authenticators a lot of the time, because you don't want to have all your same credentials in the same bucket. Now, Passkeys help with this because they are syncable, and I can use them across many devices. But a lot of the time, as I mentioned before, those credentials are locked into certain what are called identity fabrics. They're locked into my Apple iCloud keychain account. They're locked into my Microsoft Windows Hello account. They're locked into my Google Federated account. There's no good. This can help facilitate that crossover between these different fabrics, and also allow for better use cases of multiple authenticators. So we can have multiple credentials. You should, I think, and it's actually going to be easier for the user. But you should also have multiple authenticators, and having a flow for handling things like import-export could lead to things like, where I don't necessarily, if I create a credential with one authenticator, I don't necessarily need to go create a bunch of other credentials with my different authenticators. I can potentially import that same credential into different authenticators and have it available across, different fabrics and different devices, if that makes sense. So having this format for the transmission of credentials is also going to be super important, especially as modern identity standards rely more on user bound and device bound credentials. Being able to move credentials that are associated with, say, MDLs or verifiable credentials is going to happen, and transmission is going to need to happen in a secure manner. And so being able to define this work now for those other standards and for ourselves over in W3C, or really in WebAuthn Working Group and Fido Alliance is going to be important. And it helps provide this more seamless transition, I think, in the long term, and I think this is pretty far out, between credentials as they're used by users, devices, and workloads and units of computation. I think that as user and really like computer credentials become more similar, there's going to be more crossover, and having not only a format for these credentials but a way to securely import and export them is going to be really necessary. So there's generally there's been there's been a lot of support so far for all this work, especially from Apple and Google, but also from the other credential providers. As I mentioned before, it's like we wrote this with Dashlane. We've been working a lot with Bitwarden, NordPass, Keeper, Passvault, and other providers to really make this work. And everyone's pretty jazzed about it, I'd say. And then the current kind of roadmap for how we're going to put this together is in October, Fido has another plenary, and we hope to talk about it then. And then in November, the IETF is meeting for, I believe, 118 in Prague. And if this work doesn't get picked up in Fido, it's going to get picked up in IETF. It's currently being drafted by myself as an internet draft, and it can move into Fido, and there's discussion of it moving to Fido. I am not picky. As long as as this continues development, it can live on the moon for all I care. So we're also working with a few other providers, like I guess I can't mention any by name, but we're working to align on a PSC development between a few different folks. So getting early feedback from folks here is also appreciated, but definitely not expected. We're still in very early draft, and the document is pretty non-normative at this point. But if anyone feels compelled to do so, feel free to reach out. You can reach out to me at nick.steele@agilebits. You can also check out the GitHub repos for cred migration, or I guess now crimp and crimp data. Over in our org, which is the Credential Provider Special Interest Group. We're having a lot of these discussions within the Credential Provider Special Interest Group, which meets, I think, every 4 weeks now in the Fido Alliance, which I chair with, or co-chair with, Dashlane and Apple. If you're also a credential provider, you're free to join. As this develops, I imagine there'll be more public forums for discussion of it, but if not, feel free to reach out, and I can invite you to all the channels and Slacks and Discords. But that's kind of like where we're at, and I'm happy to take any questions now on the topic. All right.
I have a few questions / comments. One is we have had reports of some password keepers getting hacked. I think very recently, where they lost. I mean, it's basically a concentration of all your credentials in one place for an individual, and also it's almost like a honeypot because it has so much information stored away. Was it LastPass, or was it something like that got hacked and they lost a lot of? So these are some of the dangers with this sort of. Am I not correct? Did that not happen, or is it, am I imagining things?
So LastPass did experience a breach. You can read a lot of articles around how it happened, and this is not the first time that they've experienced a breach. What I'll say is, most credential providers have different security models and different threat models, and credential managers as a whole are a better way to manage and create and manage online credentials for the user. They create credentials with higher randomness that are harder to crack, that are and change your threat boundary from, in the case of like generating or generating passkeys, right? If I generate a passkey and store it on an authenticator or store it in a credential manager, an attacker would now really need to have access to my physical device in order to get access to this passkey. Now, they could potentially, with a fair amount of effort, get the keys that they need to crack into a credential manager account, but it definitely raises the amount of resources needed to do so. And so each credential manager is a bit different. 1Password, Dashlane, I believe Bitwarden and others, we all have white papers published that explain how our cryptography works and how our applications work. We're pretty open about it. I can't speak to, I can't really go into depth too much on why I think LastPass experienced an issue here, but I do think that on the whole, using a credential manager is better than not using one at all.
Yes, I mean, it's evident, but like I said, if it leads to a concentration of things in one place, people get more by attacking something like that. But anyway, let's leave that aside, because that is a specific breach for a specific password manager. Now let's move on to your suggestions for this. One of them, the most important one, which you talked about here, is basically the protocol itself of the key exchange and the encryption and so on and so forth, right? I mean, that's what you focused on in this presentation. So the standard Diffie-Hellman, excuse me, and then of course the hybrid key thing that you talked about. So anyway, it looks like somebody else has a question, but I would like to continue this this kind of exchange about this whole process. He seems to have asked a question, so I'll withdraw for now, but I'll come back once you have answered his question.
Well, I was actually appending to your question. Would this key exchange allow, the way it's written now, do you guys envision this transfer working between, say, a credential provider and self-custody of passkeys?
Yes, 100%. This shouldn't be, if you are able to I mean, this is why we want to standardize it. If you can make if you can generate your own export request, you can have your own passkey provider, you could have your own credential manager, you can make one from scratch. But you know, what we want to standardize is the ability for you to say, hey, I just wrote my own credential manager that I trust, and I want to move from, you know, 1Password to that new manager. If you can create the export request and parse the import response, then like you're good. And that's, so we want to make this accessible for everyone and really enfranchise all credential providers and managers.
Okay, so to the earlier question, it would make it easier to go to a hosted provider or to my own local whatever if it supported the protocol.
Yeah, and in the case of local providers, I believe like Passvault is kind of a more local provider. We envision a way where we can just provide a more equitable way for these transitions to work, where we don't need to, you know, support specific managers and providers if you want to do import export. We're just all going to start talking the same language.
Okay. Thanks.
So to continue, that one we just talked about, where, you know, if it's a local provider, basically it's going to be, you know, some kind of a vault where that data is stored. And now then, if I can put that vault onto a commonly accessible backplane, then I can access it from another device, even though, I mean, is that correct? I mean, even if it's locally hosted, so to say, meaning that it's not in a central location with the, like a, you know, like a hosted provider.
So I will say that this is out of scope for the discussion of credential import export. So for this protocol, we make no assumptions about the credential manager and the security properties that they're in. As I said earlier, the credential managers and credential providers that are commonly used all have sort of slightly different security properties and threat models that they use. But all generally will publish a white paper or some public documentation around how they work and how they store credentials. I would say that would probably be the best way to figure out how this works behind the scenes. I encourage you to look at the 1Password's white paper that we publish online, and I'm happy to provide that link later. But I'm not making any assumptions, and I'm not, and the storage and of the vault is sort of out of scope for when I'm talking about credential transport.
Okay, sounds reasonable. Well, of course, you know, the reading of a white paper like that and figuring out the security properties of the protocol, especially with respect to whether the actual implementation follows that white paper, is a slightly sophisticated, you know, ask of any user. I mean, it's not going to be a common user that's going to do this. It's going to be just security researchers or cryptanalysts or, you know, somebody else who's going to do those kind of things. So yes, I mean, in the sense it's open source, that like that. I mean, the method itself, that is a very good thing. I'm sorry, am I not being heard properly? Is that why you're leaning forward, or?
No. I agree. It's just, I think a similar argument can be made for taking the COVID-19 vaccine. It's just like, I don't necessarily, you know,
No. It's not I mean, okay, let's not go to the vaccine thing.
No, for sure.
All right.
It's you know, it's the same case of like, I think there's a more friendly example of it would be like any other system that you use, your Google Chrome browser. You have to have some amount of trust within the provider to
I mean, you know, obviously, even the working of a simple thing like a toilet in your own house, you got to have some notion of Bernoulli principle to know why it works. Okay, so that's.
But you know, it's like when I feel like there's an argument to be made. It's like I'm not saying you have to trust the science. You can read the paper.
No. But what I'm saying is when I'm putting forth an argument like, oh, I have a white paper, you guys can read it and you can see. So then, you know, then that's what prompted this counter, not like, you know.
Yeah, for sure.
Not a generic, you know, statement about the technical imperviousness to normal folk of any solution.
Yeah. No, I agree. I think it's in most cases, there's going to be some amount of trust necessary that these systems are going to operate in the way that they do. But when it comes to what we really want to, you know, have, if the sort of roots and anchors of trust in this with regards to this protocol is that the when the credentials are in transit, that they are encrypted in a format that will, you know, be safe for storage, and also you know, there won't be a possibility of saying downgrading the encryption of those keys. You could potentially generate a, you know, if I have a here to kind of go back to the example, and I'll share my screen again. If I have an importing app here, that could potentially provide a type of public key that results in the derivation of a weak symmetric key, then when that data is encrypted, I could potentially exploit that weakness and decrypt the data without necessarily needing the private key outright. That could potentially be dangerous. But generally, if we're trusting certain curves used for Diffie-Hellman or for HPKE, then that's where the roots of trust lies. Are we trusting that the cryptography and the curves being used are sound here?
Yeah. I mean, that's a basic assumption in every sort of exchange like that, right? I mean, because you just want the protocol itself to be secure if it is done properly, quote unquote, right? I mean, that's an assumption. That's an assumption we are willing to make, I suppose, most of us, because we we use TLS without being aware of the minutiae of how it works,
right?
And we think that our providers are trustable.
Right.
Oh, Tim Spring has got his hand raised.
I don't have my hand raised, Pippin. Sorry for the confusion.
Oh, maybe yeah, it's me. I am to blame because when I put it over your rectangle, it comes up with a raised hand. Anyway, back to so the thing that two things. One is, of course, any kind of interoperability sort of area or ecosystem is a source of vulnerability because obviously if both the the source and the sink systems are pretty secure, it could be that, so obviously I understand why this needs to be very foolproof, because that otherwise it would be the weakest link, weakest point in the attack surface. The other thing which you did mention, and which I guess we didn't go into, was the format of the actual exchange itself. Are you guys working on that, or is it? I mean, meaning, are there standards for this sort of thing?
Yeah, so this is there's two there's going to be two separate drafts. There's going to be one for the protocol itself, and then one for the data format. There's not a lot of pre-existing work that I found that that's really great for transmission of sensitive material. I've been taking, I think, a lot of inspiration from Brent Zundel and Olivier, I can't remember his last name, but over at Spruce ID from
Turbo.
Oh, sorry,
Turbo. Turbo.
Yeah. So they've been working on a lot of stuff with regards to JOT formats, and I think a lot of those really coincide with what we're thinking about now. But you know, as I said, it's like very early days there. I think I have a meeting starting tomorrow to kick it off in earnest, but I've been mostly focused on the protocol side of the house and getting folks aligned there.
Okay, because I think that's obviously another key item, the format.
Absolutely, and I think the format is really going to be, it's important to have a format that is able to accomplish, like, not only just the movement of credentials, but the reference of credentials and pointing to credentials that may not be able to move, and also being able to handle things that may not be, you know, conventional credentials. It could just be raw data, or even, you know, maybe it's bytes provided for a PDF, and the PDF is being used for some format. Heck, maybe someone has shimmed byte data into a PDF file, which I've seen before. So there's a lot of different formats this data can take, but being able to have a standard envelope in which to package those discrete credentials and the data associated with it is really important here. And then also being able to, you know, if I move a passkey that is potentially, you know, ESDCA, or sorry, elliptic curve 256, and I move it over to some credential provider that is not capable of using, say, elliptic curve signatures. Being able to have a way for that other manager to say, hey, maybe, or I can't use this. So I can either do one of two things. I can go reference or go talk to a credential manager that can do it, like the credential manager that just tried to export it. Or I can go to the relying party or the website and say, hey, I have,
somebody's giving you a lot of balloons.
My news, what's it? The new version of Mac OS Sonoma added a reaction layer. So the other thing they can do is go to a website and say, hey, I have this old credential, I can't use it. Can we figure out how to make a new one? In a lot of cases, I don't think they may be able to do that outright without the help of the old authenticator, but this opens up paths for remediation, which is really also going to be necessary here, because as I mentioned earlier on, there's a lot of cases and a lot of times where, you know, if I import from one provider to another, I'll end up with 5, 6 more credentials that have been improperly imported. And because they're either, you know, not in the proper format, or they're like a credit, you know, it's a credit card and it just isn't unpacked properly. So it ends up being the other provider thinks it's a note, so it gets put in the wrong category. There's lots of sort of
yes, I'm very familiar with this phenomenon, having worked around these kind of problems for a long
Yeah.
time. And I think, on the very in a very basic sense, it's almost like casting, right? I mean, you have a type, you want to cast it to some other type, either lose information along the way because of whatever,
Yeah.
the representation doesn't support it, or there are it's a basic problem in computer programming, I believe. I mean,
Oh yeah.
it's
Well,
I mean, if you track
AI,
it back,
ChatGPT will solve this, right? We'll just pass the credential through the AI, and they'll be like, yeah, I know what that is.
maybe inject some hallucinations into it, and then left with a credential that is just you and a merge of you and Yoda or something. I mean, who knows? So that's all. The problems are. What I'm saying is, I am pretty sure many of these problems have been looked at in other fields, and I'm basically urging you to take a look at some of those areas, like for example, DIDCOM, very simple thing. I mean, it's not simple, but communication between two through a third medium, which is not secure, and they had to figure out a lot of these kind of problems. So, basically what I'm saying is maybe you can be helped by looking at some of these things. And I am also the chair of the Interoperability Working Group in ITU, which is to do with transporting digital assets across different, let's say, ecosystems, like a cross-border currency, exchange. So, not to belabor the point, but what I'm saying is, your problem has similarities to other problems, and maybe you can take a look at some of those to help.
Oh yeah, no, I yeah, as I said, it's like I've been talking with Brent and Oliver and Olivier, and I'm definitely interested in DIDCOM as well. I think I'm trying to. There's a lot of recent and existing sort of thought in the space, and I'm definitely interested in incorporating.
Yeah, so I would definitely help if I can.
That'd be great.
And I think we have reached the end of our time, and it was a wonderful talk. Thank you for handling this important topic.
Well, thank you for having me, and I'm glad I'm able to speak to you and the rest of the Hyperledger folks about it. So thanks for having me.
Yeah, thank you, Nick.